Lesson 11.2, the Pythagorean theorem. Essential question is, how can you find the measurement of a missing side using the Pythagorean theorem? So like the name suggests for the theorem, it's by a Greek philosopher called Pythagoras, and you're going to have a couple of conditions for this theorem. First, it has to be a right triangle for the triangle to use the Pythagorean theorem. So when you have a triangle with a side A, B, and C, they're going to have the right angle. And when you have the sum of the two shorter sides, which are called the legs, and if you square them and add it, it's going to equal to the squared length of the longest side, which is the hypotenuse. So the equation is going to be a squared plus b squared equals c squared, and it has to be equal when you add those squared number of a and b. So let's see. Let's first find the hypotenuse, which is going to be the longest side, using the Pythagorean theorem. Let's say we have a triangle with A and B. It doesn't really matter which side is A and B because you're going to eventually add them together. So one side is going to be 21 centimeter and then the other side is going to be 28 centimeter, and we're missing C. So using that equation, we're going to just plug in the numbers. So A squared, which is 21 squared, plus B squared, 28 squared, equals C squared. We don't know what C squared is yet, but we're going to work with these two numbers first. So when you do 28 squared, it's going to be 784. And then when you do 21 squared, that's going to be 441. So when you add those two numbers together, you're going to end up with 1,225. So that's going to be C squared. Now, in order to find out the number that would make 1,225 when you multiply the number itself, you're going to basically find the square root of 1,225. So I'm going to put a square root sign over, and what I can do is in this lesson, I don't mind if you use a calculator. So if you have your phone using as a calculator, or if you have a scientific calculator, you'll be able to find a sign that looks like this. So you'll have a square root, x inside, and you'll have a small 2 on the side. That means you're going to have squared. So when you press that, you're going to have an answer of 35. So the length of the hypotenuse is going to be 35. If you're not sure, you can always do 35 times 35 and see if it's 1,225, which is correct in this case. So I was able to find out my hypotenuse using this Pythagorean theorem. Sometimes they're going to give you the hypotenuse, but then you may be missing one of the legs. So let's go ahead and find a leg using the Pythagorean theorem. Let's say we have a triangle with one of the legs as 6 inches and the hypotenuse as 10 inches. So you're going to be missing a side. I'm just going to call it B, and I'm going to plug it in. So it's going to be 6 squared plus B squared equals 10 squared. When I simplify the numbers, it's going to be 36 plus B squared equals 100. And in order for me to find out the B, I first have to leave B on one side and then move everything to the other side. So I'm going to subtract 36, and when I do 100 minus 36, I'm going to be left with 64. And I have to find out what B squared would make 64. So I put B equals square root of 64, which is going to be 8 in this case. So I can find out one of the missing legs as soon as I know the other leg and subtract it from the square root of the hypotenuse. We have these numbers called a Pythagorean triple, which is basically 3 positive integers, a, b, and c, that would make the Pythagorean theorem true. And The easiest one is going to be 3, 4, and 5. The longest one is always going to be the hypotenuse. A and B really doesn't matter which side takes 3 or 4. And any numbers that would be a multiple of this 3, 4, and 5 in the same ratio can also be the Pythagorean triple. So for example, 6, 8, and 10, the triangle that we just worked with, has Pythagorean triple, or it can be 9, 12, and 15. So anything that would have the right ratio of it, you're going to call it Pythagorean triple. We have another one. Another common one is going to be 5, 12, and 13. Again, it doesn't matter. You're always going to use the longest side as hypotenuse. And same thing when you have the same ratio multiplied to this 5, 12, and 13, you're going to have 10, 24, and 26. That's also going to be a right triangle using the Pythagorean triple. We do have more Pythagorean triples, but we're going to mainly use these two numbers, 3, 4, 5, and 5, 12, and 13 in your questions. So using the Pythagorean theorem and also the Pythagorean triples, you can identify if your given measurements are going to satisfy and make a right triangle. So oftentimes they're going to say, can you form a right triangle with the 3 given length that you have? Let's see, let's use 4, 5, and 6 meters. If I have any 3 given numbers, the longest side, like I said, is going to be your hypotenuse. So it's going to be 4 squared plus 5 squared equals 6 squared. 4 squared is 16, 5 squared is 25, and 6 squared is 36. When you add 16 and 25, it's going to equal 41, which is not the same as 36. So these 3 measurements are not going to create a right triangle. However, if you are trying numbers such as 6, 7, and square root of 85, but you're going to put square root of 85 as the biggest number because it's going to be somewhere in between 9 and 10. So you set up your equation as 6 squared plus 7 squared equals square root of 85 times square root of 85, which is going to be just 85. So when you do 6 squared plus 7 squared, which is 36 plus 49, and that would actually equal to 85. So this numbers are going to make a right triangle. So by plugging into the Pythagorean theorem, you can find out if it's going to be a right triangle. If you have numbers that are part of the Pythagorean triples, you can go ahead and just give me the ratio and say if you have this ratio, it's going to be the Pythagorean triple, so you don't have to show me the whole process of finding out if they are equal on both sides. So for your homework today, it's going to be from textbook 595, 2 to 22 even. And if you watch the video all the way through, next to your name, give me a Pythagorean triple that I did not use from this lesson. So it'll be a 3 number set that would make a right triangle. They have to be integers.